first chapter itself you have got, that is electric charges and fields, basic properties of charge, out of which I have picked only 3 and each points carries 1 mark. This gives the value of high resistance to be placed in series with a coil of moving coil galvanometer to convert it to voltmeter. The component of total magnetic field of the earth along the direction in the magnetic meridian is called as horizontal component of earth's magnetic field. Hello everyone, I am Brinda, Faculty of Physics from Vidhyaashram Pre-University College, welcoming you all session 2 of Model Question Paper Revision. So in today's class, let us just deal with part C as well as part D of the question paper, which has got 3 marks as well as 5 markers. Okay, so you have 3 marker, 9 questions, out of which you have to write only 5. Okay, so that is from part C. So it is answer any 5 of the following questions and each carries 3 marks. Okay, so here first question lies like mention 3 basic properties of charge. In the first chapter itself you have got, that is electric charges and fields, basic properties of charge, out of which I have picked only 3 and each points carries 1 mark. Okay, you can just note down these or else you can just add up from the first chapter with the points which is given to you. Next is derive the expression for a drift velocity in terms of electric field and relaxation time. So there is a derivation, expression in chapter current electricity. So from there you will have to pick up that derivation and start with the description. Consider a conductor of length L. For every derivations, there has to be a small description, then a diagram, then the solving. Okay, without the diagram you can't move forward. So diagram is very much important. Along with that you need to have some description, equations, mention it as equation 1, equation 2, all those, and finally arrive at a equation which relates, that is electric field and relaxation time for the drift velocity you will have to mention. Okay, so next, so here you have given the equation and its vector forms, and in the absence of an external electric field, the free electrons are in the state random motion. That means to say, sum up the initial velocities and final velocities of these concepts and get an equation, and finally you will arrive at a equation which relates your drift velocity, relaxation time as well as electric field. Okay, finally you will have to mention what is meant by VD, what is meant by E, what is meant by small letter e, divided by what is meant by m, what is meant by t. All those labeling of the terms of the equation is very much necessary. So you can go with this derivation or else the derivation which is done to you. Any derivation prescribed to your second PUC is valid. Like you can simplify as it is given to you. Okay. Next is 32nd question. With a circuit diagram, we need to explain how a galvanometer can be converted into voltmeter, or else even the question will arise conversion of galvanometer to ammeter. Either of the two question is very much important. So it's very easy. First of all, you will have to draw a diagram. Okay. So the voltmeter is the one which is used to measure the potential difference. As it is used to measure the potential difference, it should be connected in parallel with the component which across which the PD means to say that it is a potential. Its potential has to be measured. Okay. So now the potential difference should not change. All these are the things like how exactly we should go on with the experiment in order to convert the galvanometer into voltmeter. This is the very much necessary line which you'll never have to miss. That is, the high resistance should be connected in series with the coil of the galvanometer. So this high resistance must be, it has to have a high resistance which is effective. Okay, so How exactly it is effective? That is by connecting the high resistance in series, it affects, that is the galvanometer can be converted to voltmeter is what they are talking. Okay, so this is the very important line, that is the high resistance is connected in series with the coil of the galvanometer. The moving coil galvanometer with this modification is called as voltmeter. That is, successfully the galvanometer is converted to voltmeter. And this diagram is important. And next it turns out to be, you will have to label G means what, R means what, IG means what, and then get the conclusion by this equation. Okay, so this gives the value of high resistance to be placed in series with the coil of moving coil galvanometer to convert it to voltmeter. Okay, this is the final conversion of galvanometer to voltmeter. Okay, so here you will get for 3 marks. Next is, we have to define the terms. This is from the chapter Magnetism and Matter. Here we will have to define 3 of the magnetic elements of the earth, that is declination, inclination as well as horizontal component of earth's magnetic field. Okay, what is the horizontal component? Those 3 also have got some definitions. Those definitions are given below. Declination, angle between magnetic meridian and geographic meridian of the earth at a place, this is called as magnetic declination. What is inclination? Inclination is also known as angle of dip. Okay, that is the angle between direction of total Earth's magnetic field and horizontal line in the magnetic meridian is called as the magnetic inclination. All these are done to you in Magnetism and Matter chapter. So you can just get back to the session and check this concept. Next is horizontal component of Earth's magnetic field. Again, the component of total magnetic field of the Earth along the direction in the magnetic meridian is called as horizontal component of Earth's magnetic field. I hope you you're noting down all this. This is very much important. Please study things, either the definitions given here or else the definitions which your respective teachers have given. You will have to follow it up so that it will be, you will have to follow it up. Okay, so these 3 are the important terms, okay, which you will have to define from the chapter Magnetism and Matter. Next is, you have derive an expression for motional EMF induced in a rod, okay, moving in a magnetic field. So this is very important concept. So it's very easy also. From here till here, it's the description of this diagram. So this is a diagram in which the uniform magnetic field is being produced as given here, and a rod of length X. This is the rod, okay, this is the rod of length L. So here it is moving in a uniform magnetic field, and that field is called as B, as you all know. So uniform speed is known as V, vector V, and then let the rod be moved from position PQ to SR. So that distance it covers dx and time dt. So these are the important main key points. Having this, you will have to just the area, you will have to calculate the area swept and the change in the magnetic flux, how it's given, because you already know the equations of magnetic flux. All this concept you will have to write and finally end up with this equation where you know that dx by dt is velocity of rod, what is B, what is L, what is B, all these concepts you will have to write. So this is the relation. Here you will get 3 marks. Okay. Next, we are going to ray diagram for the formation of the compound microscope and the expression for the magnification produced by the microscope we'll have to write. So while writing the answers, please read the questions properly, because in one single question you will have 2 split questions also. Simply don't draw the ray diagram and just keep it. You will have to even write the expression for a magnification which is produced by the microscope for the image which is formed at infinity. Okay, so this is the following diagram. So I hope you can just refer for ray optics and optical instruments chapter and get the diagram done. And next it is expression for this is the second part of this question. So expression for a magnification which is produced by the microscope for an image formed which is at infinity. The expression is given over here for the magnification, wherein what is L is a separation between object and eyepiece. All those terms you will have to mention. Next we are going on to 36th question of the same part C, that is 3-marker question itself. So we will have to arrive at the expression for the radius of nth orbit of electron in a hydrogen atom. These many days you had atoms chapter for 5 marks in part D, but now 5-marker thing has been gone, so it is only in the 3-marker question only you will get. So they might ask about the radius or the orbital velocity, all those, okay? So total energy, probably they may not ask because total energy, it's a very long derivation, consists of 5 marks. So probability is more for this radius of nth orbit of electrons or else your orbital velocity. So here it goes like you will have to consider an electron of mass m and the charge which is revolving around the nucleus of charge plus Ze, and the stationary orbit it has got. So the radius is said to be stationary, that is r itself, with the speed v. So that will be the description. Here is the diagram for which you have some set of equations which is given over here. The same equations is been written or derived for you in my session classes, okay, that is atoms class. Okay, you can just follow those sessions and get back to it. So now finally we will end up with one equation, and there ends your derivation of your derivation of radius of nth orbit, okay, of an electron in a hydrogen atom. You can either refer for this derivation whatever is given, or else refer for the derivation which has been given in the session classes, okay. So those, whichever you feel it easy, step by step you will have to check it out and you will have to do. Please don't skip any of the steps in case of the derivation, because there are specific schemes and specific marks which is allotted for the respective answers, respective equations. So finally you have your Bohr's postulate. With that you will just equate it, and you have got for Z is equal to 1 because you are calculating for hydrogen atom, you will end up with the radius in this manner. So this gives the expression of radius of nth stationary orbit of the electron in a hydrogen atom. Next we are moving on to 37th question. This is from the chapter Nuclei, and it is the numerical, as I told you, which comes with respect to binding energy, mass defect, all this. It is revolving around those concepts itself. So you will have to refer for the nuclei chapter. In case of nuclei chapter, you will have to refer only for the numericals part, that is the binding, how to calculate binding energy, mass defect, specific binding energy, all these, it revolves there and then itself, okay. So now here you have calculate the mass defect and binding energy of the nitrogen, given the rest mass. These are the things which is given, okay. So given things first you will have to write. To calculate is what? Mass defect and binding energy. So you have the mass defect and binding energy equations. You follow that, get the values by solving. Please don't use the scientific calculator, because for you will have to use the ordinary calculator and calculate, okay. So next is calculation of binding energy, okay. Binding energy for 1 unit is, you know, this is the binding energy. So whichever answer you have got at the previous, multiply it with 931.5 mega electron volt. In that you will get your binding energy in that. Please remember, answer is must and your unit is also must. If you don't write your units, you will lose 1 mark, okay. So next is 38th question. Any 3 differences between p-type and n-type semiconductors? You can go like this. Either you can take all 3 differences, or else you can take 2 differences with 1 example. Either of the 2 you can just opt for it, okay. So keep it simple as it is, because they save your time and then it will be very much useful. The remaining time you can just revise your things, okay. Next is 5th Roman number, which deals with a part D set of more questions, and part D questions of the 5th Roman number as well as 6th Roman number, everything is for 5 marks, maximum for 5 marks, and very easiest part. Okay, so here you can predict which are the derivation which comes. Okay, so derive the expression for the electric field at a point outside a uniformly charged spherical shell. So what is the value of electric field inside the shell? That is also a question. So it's applications of Gauss law, the last derivation, and just one line, that is what is the value of electric field inside the shell. Inside the shell it is 0. Okay, inside the conductors the charges are said to be 0. So write the description, write the diagram whichever is given to you. Calculate the fluxes, like on the surface, what is the electric flux what you have got, and then go with the theta, its angle, and whatever is there, simplify it, solve it. Remember to mention all these equation numbers, and then you can solve it. Either you can solve in this way or else you can solve in the way I have given it to you in the session classes. Okay, finally you will end up with the equation. So remember students, this equation, it's like this gives the expression for electric field at a point outside the spherical conductor is what you will have to write. So here ends one set of things. So till here you may get 4 marks, and one question is left out. It's inside the conductor's Q is 0, so E is also 0. Electric field at any point inside the charged spherical shell is 0. So the next question turns out to be, that is the 40th question. Remember, 39th question starts from your part D. So this is the second set of question. We have to obtain a condition for balanced, that is balancing the Wheatstone's network. So balancing the Wheatstone's network, if very important question this is. Remember to draw the diagram, remember the arrow marks to be put over here, and remember to write I1, I2, I3, I4, whatever is given, PQRS, okay, the bridges of resistors, and the galvanometer, as well as the power supply and the outer arrow marks. Everything has to be very neat. And remember to give the direction, like how exactly you take the direction, either this way or this way. The direction, whatever you consider, that direction will have to be mentioned within the Wheatstone's network. Next is, just give the descriptions as Wheatstone's network. It consists of 4 resistance PQRS, which is connected in a cyclical order. A cell of EMF is connected between A and C. This is A as well as C. Marking has to be must and should. Okay. A galvanometer of resistance G is connected between the points B and D as shown in the figure. So galvanometer is connected between point B as well as D. So there ends your description and diagram. Then now you step into Kirchhoff's current law, Kirchhoff's voltage law. 2 laws you will have to, by applying all those laws, you will have to solve it. And finally you will end up by PQ is equal to RS, which is the balancing condition, keeping IG is equal to 0. So this is also very much important. Okay, so please remember the arrow marks are must and should. Without the arrow marks or without the diagram, your paper won't be, that is the questions whatever you write, though you write the full thing correctly or properly, it won't be valued or the marks won't be given to it. Next is third question, that is 41st question. Arrive at the expression for the force per unit length between 2 infinitely long straight parallel current carrying conductor. Hence, we'll have to define the ampere. So this is also one of the most important concepts. The diagram has been tilted. It's the same, like tilted or the straight, however you want you can draw. But the components, whatever is given there, has to be perfect. The description is given. You can just read it. You can just pause it. You can just write down the things and then you can learn. And next is, there are magnitude of the magnetic field produced by one conductor, magnitude of the magnetic field produced by other conductor. There are 2 sets of equation. And next is the force, that is F1 to 2, F2 to 1. Just relate the equation, both are one and the same. So if both are one and the same, you can just write as F12 is equal to F21, which is equal to F. So writing the equation, you will end up by force per unit length. You have nu naught divided by 4 pi to I1, I2 divided by D. What is F? What is nu naught by 4 pi? It's a constant. What is I1? What is I2? And what is D is what you will have to mention once after you just write the equation. And after this, you can just apply, like if I1 and I2 are 1A, D is 1 meter, L is 1 meter, nu naught value you know, then equation 5 becomes, why are we doing this? because they had asked us to define, hence define 1 ampere is what they had asked in the same set of question. That is why I told read the question properly, for which the definition has been given over here. Okay, so all these are part D question, which consists 5 marks, and next question turns out to be very important, and you can predict this. This is the very easiest derivation and most important one. Okay, so it's a lens maker formula. Please see to that you draw lens neatly, draw the diagrams, draw the arrow mark, incident ray, refracted ray, from where exactly it's passing, all those principal focus, focal length, optic center, all these you will have to write properly. After which you can just see that refraction at ABC, that is one part, what exactly is the refraction taking place, and get the equation. And you will have to mention what is OB. OB means it is U, and which represents B, that is the image of the object. And then refraction at ADC means the other side of the refraction you will have to set. And then you have to equate the two equations as given here, 192 equating 192, and solve it and simplify. Finally you will end up with lens maker's formula. Okay, so for N1 is equal to 1, that is in case of air, that is rarer and denser mediums, you will have no, with respect to that you will have this equation. Okay, here ends the lens maker formula derivation. Next is define threshold frequency for photoelectric emission. Write any two experimental observation for photoelectric effect. Likewise, you have 3 set of questions. See here, write Einstein's photoelectric equation and explain the terms. These are 3 set of questions. I told you at the beginning itself. Part D, last 2 things, that is from dual nature of matter and semiconductor electronics. It's a split question. 1 plus 1 plus 2 or 2 plus 2 plus 1. All these concepts all this probability occurs in case of the split questions, in case of dual nature of matter as well as semiconductor electronics. So in both of the cases also we have that threshold frequency. It's a, what is that threshold frequency? You will have to define it. It's been given over here. I hope you can read it and study. Okay. Next is experimental observations of photoelectric effect. There are certain experimental observations. You can just give, they have mentioned any 2 of the experimental observation. You can mention 2. And write Einstein's photoelectric equation. It's a very small equations and very important also. In session classes itself I have done it to you, mentioned it, it is important, and then explaining the terms, it's very much easier like this. Okay, so this is the equations which is given over here, and then you can just explain the terms. Okay, so that's all about your dual nature of matter question. And finally we are going out with the 44th question, semiconductor electronics. This is also split questions. What is rectification? Circuit diagram and input output waveforms you will have to draw for full wave rectifier. Explain the working of full wave rectifier. So what is meant by rectification? Converting AC to DC. What sort of DC? Pulsating. Remember to mention this word, pulsating DC voltage. Pulsating voltage is called as a rectification. Very much important. Don't directly write into DC and keep quiet. It is pulsating DC. Circuit diagram, input output waveforms. This is a circuit diagram. Please see to this carefully and draw this. Mention all D1, D2, RL, SP, AC sources given here, transformer, this is the transformer. All these mentioning has to be done. And then this is the input waveform and this is the output waveform. You will have to mention input here, output waveform here, and this mentioning things also has to be there. Okay. Next is working of PN junction diode as a full wave rectifier. You can see completely when the AC voltage is converted. However, you start explaining the circuit, how it works. In the session classes, I have done the same thing. You will have to put it on your paper. You can, if you read this, you will understand it better. Okay, so next we are going on with the numericals, and that is any 2 of the following out of 4. Okay, those 4 numericals comes only from the 4 chapters. So if you concentrate on the numericals of the 4 chapters out of 14 chapters, it's enough. Very easy, right? So first one, it is electrostatic potential and capacitance, and then it is current electricity, and then it is alternating current, and then it is wave optics and optical instruments. So if you just go with the first, that is ABC is a square of side 2 meter, point charges 50 microcoulomb, 100 microcoulomb, again 50 microcoulomb are placed at the corners ABC respectively. So we have to calculate the work done in transferring a charge of so much from D to point of the intersection of the diagonal. So this will be the diagram. Here the given terms are given, and what are we supposed to calculate? The work done. Calculate the work done in transferring a charge. So calculate is what? W. So what is the solution? Solution set has been given over here. So you can refer for the chapter 2 formula, and then that is the potential formula, this equation. So this is the formula. Given doesn't carry any of the marks, students. Formula, it carries 1 mark, and the answer carries 1 mark, and your SI unit carries 1 mark. Rest of the marks is given for your calculation set. Remember that. Please don't leave the answer. Please don't leave the SI units. Please write everything so you can score out of out. Okay. So next is continuity of that is potential at O due to the charges QA, QB, QC. Solving this, you will get this answer. See, I have not left the SI unit also. It's been given over there. Don't leave SI units along with the answer. It has to be there. Okay. So it's like you have calculated 2 of the voltage, after which you will have to calculate the work done in transferring the charges. With respect to the voltage, you can just calculate with the charge, and then you can get the work done in case of the joule. So it is microjoule, which is given over here, or into 10 to the power of minus 6 is also valid. Okay. Next is from the chapter current electricity, 2 resistors of resistance 12 ohms, 6 ohms are connected in parallel with 12 volt and 1 ohm cell. So we'll have to calculate the equivalent resistance of the combination of resistor and obtain the current through the cell. We'll also have to find out the terminal potential difference across the cells. The complete current electricity chapter, whatever formulas are there, learn it properly. Okay, so that it will be very easy. So just visualizing all these concepts, like thinking these concepts, how exactly it's been placed. There are 2 resistors. One is 12 ohm, one is 6 ohm, which is connected in parallel. So this is a parallel set. So there should be one input and one output over here. So there has to be 2 wires for which it is connected, that a source has been connected, and a source they have given like 12 volt is there, as well as 1 ohm cell is being connected over there. All these concepts will have to be put up, and then what is the things you will have to calculate the equivalent resistance and calculate the current through the cell, that is I, and the potential difference, that is V. So the solution turns out to be in this manner, having the parallel set of resistors connections that has got an equation. You will have to equate it. So there part A of that question is being done. Next is part B of the same questions, calculations of the current through the cell. I is equal to this equation we have got in current electricity. The same thing, you will have to go on with that. With the answer, you will have to mention your SI unit. Then part C, that is calculation of terminal potential difference, for which we have one more set of equation. Plotting it and solving it, you will get certain answer. We'll have to write the SI unit, that is volt. Okay. Next is, this is from the chapter alternating current, and the very easy concept also, a series LCR circuit. This is with reference to the LCR AC circuit, pure inductor of the inductance 5 Henry. That means L is 5 Henry. A capacitor of 20 micro ohm means into 10 to the power of minus 6 farad. A capacitor of 20 microfarad, that means to say into 10 to the power of minus 6, and a resistance of 40 ohm. 40 ohm, R means 40 ohm. We have to find the frequency of the alternating current, and then it is sharpness of the resonance and the bandwidth of the resonance. All these has to be found out, for which we have certain set of equations. Find out those. You even have to concentrate on the impedance as well. Okay, so you have F0 and you have sharpness of the resonance, for which you will have to calculate the factor, Q factor. So you have got Q is equal to 1 pi r root of LC formula, and you have got what is Q, and then it is the bandwidth of the resonance. You can just plot this or else this, either of the two you can just opt for, and bandwidth is given by Hertz. Okay, so that's all about your question number 47. Next we are getting on to the concept, that is using Young's double slit experiment. Okay, for which this is from the chapter wave optics. The distance of the screen from the slit is D, that is D is 2 meter. Then you have wavelength of lambda, that is 550 nanometer. Nano means into 10 to the power of minus 9. They have converted to 10 to the power of minus 7 meter. Either of the two you can do and then check on with the concept. Fringe width is given by beta 2 millimeter, that is into 10 to the power of minus 3. And the other set of wavelength, that is Also find the fringe width when the source of the light is replaced by the source of light of wavelength 440 with its nanometer, so into 10 to the power of minus 9. All these are the given terms. To find what? We'll have to find out the fringe width for the second set of questions, and we have, for the first set of question, we have to determine the distance of separation between the slits, that is small letter d, and finding out the fringe width is beta for the second set, for which you have initial fringe width. So this is for the first set of questions. So you will have distance of the separation is what we have to find out. So it is given in meters, and fringe width is what we will have to do. So it is fringe width is given in some meters. So it is millimeters. There ends your equation. In today's class, we have dealt with the model question paper part C as well as part D of the physics model question paper. Okay, so I hope and wish you best of luck for your exams. I hope you study everything whatever is being given over here logically, use smart work, use your brains, and then study and prepare for your exam. All the best for everyone. Have a good day. Thank you.